What's going on? This is pleasant parser error formatting. So yeah, what I'm going to be doing is what I just said, pleasantly formatting parser errors, namely ones like these. You have a hint, add a closing bracket here. I'm going to make this, currently this is kind of like hard-coded for this particular error type, malform section header. I want to more generally do this, so we can have some kind of template, not like a C++ template necessarily, but a series of functions that can abstract away the offsetting of this to match this caret and such. And then also having more of a general error context. Currently, it's like a single-threaded application, and we have this parser. Errors are short. The parser has a errors vec, a parser errors. We parse the file, run the request. You can see auto request equals this dot parse. If there's parser errors, we do this. Else request execute. So this logic here should be part of a file, I'd call it, because you'll have one request per file. And yeah. So you have one request per file, and we would do this logic independently for all the files. So you can imagine running more than one request. Imagine on CI you're running a folder of thousands of these to kind of validate your server or something. You can have each, for instance, not every one is going to fail in the parser. So you want to have a more general error. We already have a kind of virtual error class in a somewhat regrettably OOP fashion. Perhaps in a obfuscore freaking rip obfuscation oriented programming way. But yeah, so I'm gonna try to do right now is these two to-dos: print error head, print error foot. But in order to do this, you need to know how many errors there's gonna be, like before even printing any of them. And this kind of involves breaking the list of errors out into a context above the parser. So how do I want to do this? Probably with a new class. Probably with a new class. I also want to get away from using try except. That was just kind of how it is. I'm not really sure. I'm not even sure if we're throwing an exception anywhere, to be honest. But this just exists. And so, yeah. So the goal is to have a new app context where for each you can run multiple files. But let's make it generalizable for one file. So we're going to have a, let's look up how to design app context. Seems relevant. Dude, frick AI. I'm not talking about a state machine, I'm talking about application state. Not exactly what I'm getting at. might be a Jippity. I'm willing to see what Jippity has to say on this. Let me pull it up. See if it can be more than useless. Be more or less impressed. Should have switched to the not mini one, but whatever. Shared pointer. Red safe memory. Since multiple threads are ordered simultaneously correct the error connection, synchronization primitives, standard mode checks to guard against the vector. Got access to the vector, what much more? Security save. Create an error manager class responsible for collecting and managing errors. Encapsulate server. Okay. Each thread can maintain its own local vector error to minimize contention. After thread execution, merge these local errors into the centralized error manager. Advantages. Reduces the overhead of locking during error reporting. Improve performance and highly concurrent. So we're never going to have the... I imagine the average, or like the median concurrency is going to be like 10. Probably low. Probably, I mean, 0 users, right? So probably like about 0, but... Thread pools, like standard async, current parsing, reporting so instantiate a centralized error manager at the start of the application. When initiating parsing, has a reference to the error manager. Within each parser or execution thread, upon encountering error type, report to the error manager. Utilize the existing error.print. Error class. Leverage these, prioritize. And header and footer sections and bring errors. Yeah, I agree on this. Potential class design sketch. Error manager will have errors, error mutex, add error, show pointer error, get errors const, print all errors const. Parser main function, initialize it, advantages of this branch. Looks good. Let's begin programming that. So that sounds good to me. Let's get into it. So errors, error manager.c, sorry, HPP. So include errors. Looks good to me, as we talked about. Manager CPP. We're going to add error, lock the mutex, and place back, move. Share pointer, error manager, get errors const, lock the mutex, return the errors, sure. Center the lock guard on the mutex, lock the mutex. Error is empty, just return, otherwise. Print encountered an error. So this is where we'd print all the state, end of error report. That's nice. So, looks good to me, and we're going to do error.print on all the errors. Pretty good to me. Go in here, error manager.cpp. Go in here, this is going to be errors slash error manager.hpp. And here, D, F, G. I should probably make this. There's a lot of like warning you're not using this header errors. Probably because the implementation is going to use. I guess not in this case. Probably because it's imported in a header somewhere. So let's see what we have to do here. So it wants the error manager here. Makes sense. Makes sense. Request CLI wants include memory for the standard shared. Future. I think that's good there, yeah. So file separation, files, add option, files, check, expected 1, negative 1. Where's that bit? Expected 1, negative 1. And we're going to add that until I think it's useful. So we're going to have an error manager. Error manager. We're going to have a standard vac of futures. Okay. So this is a lambda to parse and execute a single request file. So let's just consider that for a second. So first, let's just copy this. So it looks like it's changing this to files, plural. Okay. Add option. Files. So I don't think it understands that this is like positional. Maybe it knows more than me. Files. File URLs. Specify one or more files. File URLs. This is going to be a standard vector, right? Standard string. File URLs. Okay, CY parse, error manager. Request parsers all dot value. Shared pointer request. Request to shared pointer request. So I think we can just do a standard make shared on this. Available conversion from shared array non-array parser. Sorry, what am I doing here? Should be request. Okay, internal error. So that currently does not exist. So we need to make internal error. So if we work something like parser error, internal error, HPP. So print details. Let's override file name. So this is going to make it return a shared pointer, isn't it? So internal error. Oh, can you write internal error? So we are going to have to edit parser. Parser interface. So like parse standard expected. So the constructor wants a reference to an error manager. Error manager pointer. Error manager. Include errors / error manager HPP. So standard expected. Void. So it's probably just going to want standard optional, yeah. Standard optional, standard shared pointer requests. It's going to be parse. Okay. So I'm not sure why there's a shared pointer on request. It should just be that's reported to the up. Parse body, parse assertion, error manager pointer, error manager pointer, error manager. Okay. So auto error make shared parser error. So let's do this. Make shared parser error constructor. So instead of error set points back, I'm gonna do auto error. So go to standard make shared parser error. We're going to do error manager dot add error error. And so we're returning a pointer to the request. Otherwise, return standard make shared request the request, yeah. So this is going to be standard optional standard make shared request. Sorry, standard shared. So here we'll have a const. Or would that be a const? And then that'd be a const. So error manager pointer manager. And here file name. File URL position 0. So error manager. Error manager. It's good to me. In main.cpp, main cpp. So try parser error manager, yeah. Or it's parser error. Parsing failed. Getting return. So if it succeeded, make the request, should pointer the request. So I think this is actually, yeah, that's already a shared pointer. So that's fine. Let's get the smart comment. To do here. And then here, this internal error. Here, yeah. So the only current error is internal error doesn't work. So I guess if you have the def, you don't really need the file as much. But yeah, whatever. 1 second. All right. So yeah, I'm just asking for this. This is quite simple, so I'm just gonna trust this blindly, effectively. Yeah, sure, general, internal error.cdp, just like this should be just, yes, very minimal. Not even implementing most of the functions it appears. So this is wrong, 'cause it's gonna be errors. I should put error. Details, yeah, that's fine. So, back to main. See if we can get a parser, or sorry, a compile here. No. So we have some template errors, so this is going to be GG. No matching constructor. HPP 19.7. viable. Requires one argument. Requires 3 arguments, but 1, 2, 3. Structure of a file name. Error CPP. 3, you have error kind, internal error, file name, severity, type. So let's look at parser error. Type. Error type general info. Dude, what the f— I really don't understand what this error is saying, dude. Like, implicit move constructor? So apparently this is very basic, so I'm getting roasted right now. That's because it's in main CPP? Where does it say main CPP? Oh, okay. Dude, I don't like this stack that has 20 function calls and one random one in the middle with no formatting is the one that has it, bro. Because of this. Internal error. No error kind, it appears. Yeah, wait, why would you— what the— That's embarrassing. Why would that even say that was a good idea? Oh yeah, we're gonna build an internal error shared pointer. Error kind equals internal error. Linking, yeah, I didn't like that. Okay. Just everything but main.cpp. Bye bye, Tim. So, okay. This is getting better. Let's consider another one. Let's consider JSON value mismatch. Assertion failed. Trying to make sure there's not like a seg false in any of these cases. Okay. So I can deal with this. So before we even think about adding concurrency, we're gonna make this look— we're gonna make this work. Look at this. So the error manager needs to look a little bit different. Error manager. We also haven't even tested its concurrency. So print out errors. So if there's no errors, just return like it's doing here. Print the error header. So what should the error header look like? What does it look like here? There's no error header actually. So no error header. Print each error, print error header. So yeah, we're just gonna go error. Bold DT name error. Me. Error, and then we're gonna go colon, because it's gonna be white. And we go encountered %d. Failed. Due to %d errors above. This will be errors size. So no bold here. Huh? Oh, this isn't this type, it's the more intelligent type. So why is there percent there? Where's that size? Why is there percent? What if we do? Oh, I guess we could test it by doing this and then doing examples slash post error. Percent value mismatch. Okay. So what if we did errors parser error and then we did data slash examples? What if we just did data slash examples dot slash errors slash parser slash examples slash PE. So we're gonna have to do this one twice here. Section rack. Section rack to the internal rack. So if I do 4 errors above. So that's pretty solid. So call request failed. Bad amigo. Call request. So we need to return this if there's errors in it. Like we shouldn't be returning a request that doesn't even exist, right? So like, why are we calling it? So this is called here. So if parse result doesn't have value, dot has value. So what does this return? Return pointer to the request. So if there's an error, return null. return not standard not. Okay, so that should fix that. Two errors above that closing bracket. Okay, making good progress. Yeah, making good progress actually. I'm largely satisfied with this. Failed due to two errors above. No form section type. Hint add closing bracket. Hint add closing bracket. So if it's request body assertion parse assertion line find is request. Turn standard not. So I don't think we actually want to do this because we want to keep increasing on next line. So this will keep it getting it more errors, yeah. So it doesn't return anymore. I guess I should keep eating. What is this? Parse headers request. It's gonna keep going and then it's gonna return make shared request. So if error manager dot get errors dot size, if it's not empty, return the request, else not to do make this cleaner. Had to pull it down to not just return after. Scum. Right there. So I guess it still proves that it can be that it's going concurrently in that case. So it keeps going here. Get errors are empty. Error manager dot add error. Would it detect multiple parse errors? PE post is wrong, then this is wrong, yeah. So you did a request again. From section header, on section header. Section header, section. Parser again. Bring this back. Just don't do this. If so that's gonna keep going, but so it keeps going. So if error manager dot get errors dot size dot empty if it's empty, return this, return standard not. Okay. Checking size and returning here so that we can catch multiple parser errors. And just returning after first. So you can imagine if it's request, then we do this. But it could also just be bracket something, no bracket. Then you know that that line is like that. So we can add a to do, generalize this error. Okay, so that's modest progress there. Largely satisfied. Be right back, go to the bathroom. All right, let's get back to it. So that's solid. Now let's format assertions. Actually, first, let's format internal errors. So let's just throw an exception somewhere. X dot what? Severity error. Error. So that would be like if we didn't have Wi-Fi or some junk. So how can we do that? So in the internal error print, it's going to go internal error, print details. So back in here, actually just in post.rack, let's just not resolve that. Then if we do symbols post.rack slash post.rack. Oh, wrong. Frick. Be easier just to do post.rack. Internal error. So this should be the file name. Curl request failed. Couldn't solve post. Errors above. So first, let's do failed due to errors to do one error or 2 plus errors. Now we can just do this. So why is it printing the? It's kind of weird. So you print the arrow, and you print the file. So it looks like it's not getting the file. The error is not asserting the file here. So here, file name. So in main, we're catching the exception and doing a file name. So this should be x.what main. That's the detail. So what's the constructor for this? Internal error, dude. Error CVP file name. Error type. So why is there no file name thing here? Internal error. It's an error. I don't think that's how that works. File name. Parsing it to there. Then you add on the type and the info. It's a message to the file name. Here. Here we get file name. It's inherited from the above. Sorry, I need to rebuild. Can Loki just start doing this here? So file name. It's not printing the file name. It thinks the file name does not exist. So going to the creation of this, and then we gotta look up parser. File name, info. Here's an x dot what? This should be file URL. Probably run a C test while we're in here. Okay. Details of main. See, I got this mixed up. This should be x dot what? So I should probably print this better. Going from this, so what is this? Internal RCP is 3. And I want to see parser RCP 3. So these should probably be parts of the error header. Like this. So as white space, I would do as white space 3 minus digits here. This should really just be an error. HTTP, and then as white space, and then in here save that. Go to parser error.hpp. Yeah, it's included there, yeah. So now it works in here. Correct. That's white space. Okay. Looks good to me. Okay. HTTP, that's not saved there. So why do we have this percent at the end? What is this? Failed due to errors above. Term error dot size. So details. So I don't really like that as much. Details. So this is printing something from curl request fail. So we're throwing this here. Shred. Human readable. Or standard runtime error. So instead of throwing a standard runtime error, probably just make execute. Let's just make execute return a standard optional time error. That's not what I'm trying to do. CPP standard runtime error. What is that type? Type of exception. I don't want it to be exception. I don't have errors as values. Let's do a standard optional. Make a new type called a runtime error. So this will actually supersede this. So we're gonna call this a runtime error. Sorry, runtime error HPP. And this is gonna become runtime error CPP. And we're gonna go in here, runtime error. To rename this ETE runtime error type. We're gonna have curl. We'll have internal. Internal error. Oh, so a message ETE. Oh, that's obvious. Rename ET runtime error. That sounds good to me. And then here, so it didn't pick up on that runtime error like this by VB runtime. Then here, keyword runtime error type general. This will be so this is just going to be open to the user. So error type, kind of like I imagine we did here. Error kind. So this is the error kind actually. Wait, just delete everything. Oh, that's because the harpoon is on the old one. So Berlin. Yeah, bite. Yeah, BQ. Oh my god, shut up. Shut up. So is go in here. Runtime error. Harpoon that. Runtime error. CVP. Harpoon that. These are useless. Error kind. ETE. Runtime error. Going back here, type, first type buffer section header. So this is like the, this is when we're doing all the different types of, we're overloading the constructor with all these different types. So, so we can go ahead and consider this is called a runtime error. Here, DT underscore runtime error. The errors here. Nope, it's good. So this is quite. These comments are kind of autistic. Wrap center, so we're not even doing that anymore. Share pointers and make shared. To do handle insertions and report any error assertion errors somewhere. That's implied. Okay, that's fine. Error and runtime errors. So error kind of runtime error. So remember time of runtime error kind. So this error kind is going to be within runtime error, yeah. So get a parser error. Parser error. I'm looking for here. We have an error kind. What's the definition of error kind? Error kind is a parser error, assertion error, ETE, runtime error, encapsulates both of them. This is kind of in order here. Okay. Kind, so we need codes. We get a parser error header. Parser error type is all the different ones. So you have a runtime error. We're going to runtime error, HPP. Runtime error is either curl and internal. I think curl internal is fine for now, at the very least. So we're gonna have two overloads. So in the runtime error CPP, first off, it's supposed to be a runtime error type. So how does the parser error do it? It's a const file name, info, error severity. Frick. Runtime error CPP is file. Type, error type. This is just doing a type of section header. Parser error. Internal error. so this is like a specific one. We're overloading all of them. So here we can just call this runtime error. The message, ETD, this would just be a message here. Yeah, or is it supposed to be a synopsis? But yeah, message is the synopsis, error internal. So we can have some more logic in here. Error. No matching constructor for error. Error kind. Parser error. Error kind, runtime error. So yeah, this is because I took the message out. And type, error type. So this is if you're given malformed section header info. So here we'll have to make a type malformed section header info. Curl error info. This design isn't as good here. Let's just do the message. The type is going to be a runtime error type. The curl internal. So we can just take the type here. File name first, message severity. We can just take the type as a parameter. Const time error type. Yeah, here type. Runtime error does not match any, so let's go back to the header of this. Runtime error will also have a const runtime error type. So this type. Okay. So back in error HPP, network error, runtime error. Okay, so that's right. So runtime error not saved. Let's save that. Let's compile and run that. Huh? Runtime error, did you mean standard runtime error? So standard optional runtime error request.cbps. CBP. Runtime error, so let's do this. Let's do code error slash request decoration. I guess I got the header, so I can just remove this. HPP paste. It will be used effectively directly. Execute, it's not void, it's standard optional. It might need to be even a, because we go to the definition of parse. This would be in parser, that it should be. Definition of parse is a standard pointer. Oh, this is the error manager crap. Yeah, I forgot about that. Okay, so I forgot this is like error manager junk. So the request, parser, and the executor. So I think the request should have a pointer to the error manager as well. So you're gonna have error manager reference error. Code error slash error manager HTTP. So now in here we'll have a private entity error manager pointer error manager. Okay. So what did the parser have here? Parser CPP. Constructor error manager. And you're just setting the error manager to the error manager. So going to the request. Sorry. Blend. Request store. Request here. Error manager pointer. Error manager. Method URL. Curl easy in it. Assertions we're gonna do. Here we're gonna do error manager. Error manager. Instead of throwing this is a perfect example. We can do error manager underscore dot add error. It's gonna be a standard make shared of a runtime error. Just gonna have so this is still if curl. When we're doing this, if not curl, two down, b format, bb format, if curl, turn here, not turning anything. See if we can get a code action. So what is the constructor runtime error? We need a string file name. File name. No. Message. Failed to initiate curl. Curl. Severity. Error severity. Error. Runtime error type. Runtime error curl. Type. Curl. XX. So we have a warning in the request now. Non-void function does not return a value, no control paths. So if not curl, so we need to do that again. Basically what we did just here. Curl. Is that even possible? I don't think that's possible. Yeah, I don't think this is possible because we check it before it's made. So here, this should just be a new runtime error. So we'll go here, 0VV, bang, 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 bang. From here, PV, D down. Let me actually save the message. Yeah, this is convenient. YT ding. And that'll be this. VT comma P. Here. The meshing constructor. Because I'm missing parentheses. Remove that. So why did I append it to a space? It's kind of odd. Unknown. So we can actually do it here. DTD file. Isn't there knowledge of the file here? Request. So let's make a file name here. Okay, let's do that here. File name underscore. And we'll go into the parser. Sorry. Go into the request HTTP. Have a standard string file name. And we'll do in the constructor of this. In the constructor of this, we'll have a const standard string. And make it a pointer, sure. File name. And then in the implementation, we can get this const standard string file name. Sorry, pointer. File name, comma. Go in here, file name underscore, file name, current comma. then we accept gone. Then when we call this, so we call this in parser, request. It's gonna be file name. File name. What do you have? File name, method URL, error manager. Method URL, error manager. Error manager. So looks good to me. I have one more warning here. Void function does not return a value. So it actually should not return value. DTR because it just appends it to the, yeah, it shouldn't return value because it just appends. Void, so we're gonna go for request HPP, and yeah, so this is actually void here. DTE, right, execute. So we can actually remove this as well. No errors, compile. Huh? So it looks like we'd So it looks like request.cdp doesn't know anything about my error type. Coded header is not used directly. So let's get runtime. Runtime error. Message file. So I gotta change the name of this here. DT underscore runtime error. Make bill. Make dot first, yeah. Or I guess I did that. So where's the error here? Oh, this is the same thing as before. This same error I had before. What was this? It was in main up here. Make shared. Initiation requested here. So we wanted to make a make shared. Okay, so this is in main CPP. Main CPP. We're making a shared runtime error with fire URL, and we need the error manager. And she's the global one. Error manager. Okay. I feel like that error is so large. Talking about like templates and crap. Runtime error. So is this still incorrect? Make shared runtime error. Runtime error needs a file name. Instead of string, yeah. A message. This returns a string, yeah. Car pointer. Yeah. It's kind of annoying. Error severity. Runtime error severity, runtime error type. Oh, this is a runtime error type. So not, yeah, that's not runtime error type. This is going to be a internal. Internal. So runtime error type should be internal. Internal. Hopefully we can do that car pointer to a string implicitly because it's pretty annoying. It's like it can. Couldn't resolve hostname. Oh, that was intended. That was intended. Error runtime. So when we print this, this should be like curl error or internal error. So the way we do that is in the. So where is that derived? We go to the internal error. Sorry, the runtime error. Print details. You just do a colon. Couldn't resolve hostname. So even these could use the hostname. But for now, I think that's fine. It kept running the assertion. So let's go to execute. Let's go to the definition of execute. So we don't actually check assertions. If error manager dot get errors dot empty. Can you do this? If there's no errors, go ahead with assertions. So now it should just be can't resolve hostname. Nice. So it couldn't resolve hostname. So it couldn't resolve hostname. So where are we printing this? In the runtime error HPP, print details. This should not be, so info.message is good. This should not be info.message. So error, runtime error. This message should be the type as a string. So this should be, this message should be type dot as error title. So we're gonna make a new message on the type. This is a class, so we're in the HPP, so we can have a. This can't be enum anymore then. So we just have to do as error title type, and this is runtime error type as error title. It's kind of a horrid function name. We just define it here. Runtime error type is error title. This will return a standard string. Error type is error title. It takes in a runtime error type. Runtime error type. Then it does this, which ret case curl return propagated libcurl error. Return propagated libcurl error case runtime error type internal. Return an internal error occurred. Error type header file. Make inline. Yeah, let's make that inline. Okay, cmake. Propagated might not be the best verbiage. Libcurl returned an error. Libcurl returned an error. So then, at each point, we should print an error occurred above or something. Or sorry. So every time we should have a function using format in parser that does what? So when we parse, we should like go here and say format print format. So we should have like a header Okay, printer, HTTP. We should just have some functions. So pragma wants, we should have. So this would be a, what does this return? This should return nothing, because it's like IO. Void, print, print. This is like a series of printer helpers. So one of them will be what we need here. So the reason I made this is so that in here, so what's the color.h is not used directly, yeah, sure. So also here, to do make runtime error. So printer HTTP, so print compiling. Oh, this would be a standard string. File name. And we gotta do format. So this is gonna be using format. Format print. This, yeah. Format to print. Format dot color. So we're gonna do foreground. Or this is gonna be board with format emphasis bold. Do compiling space here. We're gonna do so this is gonna be format color bright. If sorry, this is gonna want to be terminal color, yeah. Terminal color. You can do bright white. See what that looks like. No, this, so terminal color, this will certainly be white and not bold. Blend, what did I do? Compiling, and this will be PGB, file name, or sorry, we can go here, string, format string, this /n, file name, function, and a header file. So I do think we should make this inline, GD, okay, print compiling. Here we can do print running. So this should be like a green, you know, like green, just bright green. Running should be a bright cyan. We can do like a print. So running should be running. Like this. So we have these functions, and then in here it's a back in parser. Do parse in the main function right here. We're gonna do printer. We can just import from printer, yeah. You do include printer.hpp. You here. Printer, we're gonna have a print compiling file name. Okay, then when we make sure to request, we're going to do, this is going to be, sorry, in request CP. So value assertions can be implied, but here I'd like to print and execute. We can do print running. I think that's solid. That's already done there, so try this. Compiling, running. So imagine if we do this like a bunch examples, post up rack, examples, post up rack, then we go slash examples. Errors, beta, this, slash examples, JSON, B. We do examples, error slash JSON, B, slash examples, post up rack. Oh, even within those, it's not atomic. That's kind of curious. Hmm. Huh. Okay. How do you make this more atomic? So in the printer, volatile, right? Make function atomic CPP. So really, this should just be formatted in one thing, ideally. As print. It's gonna print them at the right green compiling. Can you just do this? Like, can we just do this? The P, yikes. Why I here, go here, P. Is that a thing? You should do that. Yeah, you can't do that. Scheisse. If I don't inline it, does it work? What the? I still didn't fix that. Running. Don't inline it. Link your failure. Print running multiple definition. It's circular. Compiling, so it printed this. So I ran this. Compiling this, compiling this. So these just succeeded and didn't print anything. JSON value mismatch, printed nothing. So to do make this atomic. Not necessarily atomic, I might be on a low level. But make this atomic-ish. Title switch off the section header. Man. So why does it stop? The other two is off. So let's go to man. If errors man. So this is kind of a 3D. Yeah, here P D D. How many should I get errors? Empty. And what does print all errors do if there's none of them? Just locks the menu tags. So I mean, I guess in here, that's fine. It's technically what you're talking about, whatever. Return 0. Process file, fruit file, and then we are asynchronously launching this process file. So is this already doing them concurrently? Okay, yeah. Let's go back to GPT just for this real quick. Good work so far. Now add a COI thing where the user calls request dot, it runs in the current dir -r option to run in current dir recursively. Alright, I'm getting hungry. I might take a break, get my pizza in the oven. Oh, so right now I'm gonna put my pizza in the oven, or in the reheater, and I'll be back in a second. But yeah, one sec. I lost my shoe, bro. Alright, one sec. Alright. So I got 11 minutes. I'm probably just gonna search grep to do. See if there's anything I can do that takes like 5 seconds, like this. Okay. Make runtime error. So instead of throwing this, I need to do what? Error manager dot add error. Then I do a standard make shared of type runtime error. And the constructor for that. I get reminded of that. It's a file name. So another to do. Since all uses of file URL, change them to file name. For now, just ignore it. File URL. Message. So we call that failed to open. Just do this. Rip. Oh my god, misclick century. Do this. Next one is severity. I think that's error, it's just error severity area. Last one was return error type. So return error type. You'd say failed to open file would be internal. Adding that to do make runtime error, that to do is gone. So why don't we do this file URL one as well? Rename this to file name. Search, so let's go ahead and remove this because we're doing this for now. Search grep file URL. Our URLs, let's just do this file names. Again, file URL. Rename this file name. Search grep file URL. Again, file name in file names. And one last time, file URL is gone. So that to do is successful. Okay. So let's go to another one to do. Custom error here. JSON parser. Okay. So get JSON field. So this is if response. So can I get a get JSON field? This is for use in assertions, yeah. Does response have an error manager? Not yet. So so it is correct that response is where assertions are validated. Is that not true? Where are assertions validated? That is an assertions.validate. Assertions. Vector failed assertions. So this needs to change a lot here. I'm gonna wait to do that. I'm just gonna see if there's something easier to do. 1 error, 2 errors. That's kind of what we're gonna just do right now. If errors dot size is equal to 1. This should be optimized. So this implies there's multiple. Just do this. 32 error above. 1 error above. Each is x. No, that's failed due to 0, or I mean, it's not going to be 0, but wouldn't fail due to 0 errors, but fail due to this many errors. So there we go. And this is the error footer as well. So Oh, that's satisfactory. Let's see if there's any other easy to do's. Custom error here, handle assertions. It's kind of a lot of work. Generalize this error is a ton of work. Handle assertions, so. I think I'm satisfied for now. Let's get a build here. Try to build this. Looks solid. Undo tiers above. Fine. Error footer to do. Fix the random percent sign printed the end of these. Okay, pretty sure. I mean, that's pretty obvious comment there. So assertions needs a lot of work. Expect status code, missing header, JSON code, code assertion type, string message. And you get this. So let's go to main right quick and try to do this new thing. Let's also just commit this. Data dash A. Commit dash M. What did I do in this, dude? Error manager. Better formatting throughout. Enable concurrency. So, do I also have CI on this? Yes. Resolves 22. Resolves a lot. Resolves this. Or at least concurrency. Resolves not that. Prettier standard out, so this resolves 22. Okay, that's what I just said. Resolves and then the other stuff. And it's about to resolve more than that, but just for now we can call it that. So I asked Jipity to do this, recursive flag, existing path to existing, oh, okay, file system. So let's get out of here, Q, main, CPP, let's go here, include file system. This is going to be a local header, all right, global header. Version recursive, loss recursive. Okay, let's just copy paste this, yeah. So this is after we check for version. Bool recursive is false, dash R, dash recursive. Recursive, we search for directories for rack files. So that sounds good. Modify the files options, so standard string, paths. Paths, yeah, that's better. And rename this to paths. And then down here it should be for file name and paths, yeah. So it's gonna be for path and paths. Right around. So existing path. Path. Add option paths. Expected. What is this expected crap? Just do it anyways. Expected -1 1. Pretty sure it sounds like 40 overloads, but expected min max. Min -1. Okay. So I'm not sure we're even using the file system, to be honest with you. XC, XV. Just collect rack files. Oof. Okay, so that's why I want a file system. This is freaking ugly, but perfect name size. This just looks horrendous. Let's just put this in a header, dude. This guy needs. And file system errors. All these errors, to do. Print these on verbose mode. So let's just see if that works. Like, that'd be kind of cool if it just happens to work automatically. CD build. Let's do cmake dash build dot. Did I close out on my terminal? Interesting. Appears that the pizza's done. Click // source /request /examples /post / examples. Sure. Underflow occurred reading the file. Is a directory. Examples. Post effect. Example /errors. Underflow error reading the file as a directory. Underflow error reading the file as a directory. So that strip doesn't work. So before I get my pizza, let me pull up something to watch.
I saw this tweet and I figured this was going to go places. I can't find the automatic tweet anymore. I think it got.
So we'll just watch this, yeah. All right.
got deleted. But this is WP Engine. They have been granted a motion to which that they can have their ACF plugin back. For those that don't know, WordPress not only shut down their access to having WordPress's NPM repository, so that means WP Engine can't be grabbed from that. They also got shut down to the point where WordPress took over their plugin and made it so that when you went to the ACF, you actually got WordPress's version of it. They took over the name, and so it was completely confusing. A lot of people obviously were pretty dang upset about that. You even had to check a checkbox that said if you were to log into WordPress.org, you actually had to check a checkbox saying I am not affiliated with WP Engine. Really, really insane behavior, because that is just. That is completely ridiculous behavior. But nonetheless, they've been living like that for months at this point. And so this has just happened. It looks like things are kind of turning around in a different way. So let's look at this. WP Engine just won a preliminary.
The first regulated online Bitcoin casino appeared in 2014, and since then, billions of dollars worth of Bitcoin have been wagered online. These casinos have all sorts of games, such as roulette, slots, blackjack, but one of the more popular ones I've been seeing recently is this game of Crash. For those of you who aren't familiar with Crash, here's a brief overview of how the game works. Players have a couple of seconds to place their bets before the multiplier begins. The multiplier starts at 1 and begins to increase, and players are allowed to cash out at any point, multiplying their bet by the amount on the screen. However, if the player waits too long to cash out and the multiplier crashes, then they lose everything that they just bet. This multiplier can immediately crash at 1 and all players lose their bets, but it can also go into the thousands and even the hundreds of thousands in some cases. Now, I've seen a couple videos and posts on strategies to try to profit off of this game, which unfortunately is just not possible. A lot of these casinos actually post the code behind their games, so I thought it'd be cool to take a look at this code and see mathematically why this game is just not possible to beat in the long term. The two functions we're going to look at are this generate hash function, which links the games together, and then also this crash point from hash function, which calculates the multiplier for each game. So we can see if you click on the results of any game, there's this hash that's associated with it. So I've replicated these two functions in Python, and we can see that if we plug this game hash that we just found into the getResult function, we get this 1.34, which was the result of the game that we just saw. Now when we plug the hash of the game into this getPreviousSGame function, we get this new hash. And if we look, we can see that this hash actually turns out to be the hash of the game that came just before the one we were looking at. So this casino actually gives us the hash of the very first game, so we can keep using this getPreviousSGame function, as well as the getResult function, and we can find the results of every game that has ever been played. So here we have the hash of the very first game, and basically what we're going to do is we're going to take the hash of the game that just happened, and continue to get the hash of the previous games, until we end up with this hash of the very first game. And as we go along, we're going to keep track of the results so that we end up with the result of every game that has ever happened. So after running this code, we can see that there's been almost 620,000 games, and now we have the results for each one of these games as well. We also see that the minimum result is 1, and the maximum result is this 658,000 that we saw from earlier. So here's the distribution of these 620,000 games, and this tail over here actually goes a lot further, but the bins are just too small to be able to see. So let's take a closer look at the math behind this getResult function. We can see that we're passing in this game hash, and what these first couple of lines do right here is basically create a new hash out of this hash that we pass in. And hashes are really just hexadecimal numbers, so we're taking this new hash and we're checking if it's divisible by 33. And if it is, that's when the function returns 1 and all players immediately lose their bets. This means that about 3% of the time, the game will instantly crash. When the number isn't divisible by 33, the multiplier is calculated using this function here. So here's a derivation of this formula to put it into a form that's easier to manage, and it basically turns into this 1 over a uniform 0 to 1 distribution, which is just 1 over a random decimal from 0 to 1. And a cool property about this distribution is that for any multiplier, the probability that this multiplier is less than some value x is actually about 1 minus 1 over x. So the probability that the multiplier is less than 2 is about 1/2, the probability that it's less than 10 is about 90%, and so on. So I actually simplified a little bit, going from this step here to going to the next step. They're not completely equal, and I found that using this formula here was actually off by a couple decimal places, so I'm going to use the above formula instead, just so we can get more accurate results. So now that we have these two cases figured out, we can find the overall probability that a multiplier is less than or equal to a certain amount. So we have this 3% chance that the game crashes instantly, and then we have this 97% chance that we use this formula up here. So you can see that we just copied it right over. We have the 0.01, and then we have this 0.99 here. And lastly, since we found this property for 1 over the uniform 0,1 distribution, we can just plug this 1 minus 1 over x in right here. So I've coded our final formula into Python here, and we're going to test it against the real results that we saw to see if we have an accurate formula. So let's try it with a multiplier of 2, and we can see that the real results had 52% of results less than 2, and now when we use our formula, we get 52% as well. So we could try it with a higher number such as 10. We can see that about 90.4% of results were less than 10, and we get the same thing from our formula. Now we'll try it for 100, and we can see that that matches. And now we'll try a small number like 1.01, and we can see that should be about 4.9%, and it looks like that matches as well. So now we can calculate the expected value of a $1 bet on multiplier x. So all we really need to do is take the probability of losing and multiply it by the negative $1 that we would be losing. And then we take the probability of winning, which is just 1 minus the probability of losing, and we're going to multiply this by the multiplier minus 1. For example, if our multiplier is 2, we would be winning $1. So now let's see how accurate our expected value formula is. We can see that with the multiplier of 2 here, the expected loss per game is about 3.5 cents. And based on the results from the actual games, we get about 3.5 cents as well. So now let's change this multiplier to something smaller, like 1.05. So now we're getting a loss of about 3.1 cents, and when we look at the results from the actual games, we also get a loss of about 3.1 cents. So here I've plotted the expected value by multiplier, and the blue line is the theoretical expected value based off of our formula, and the orange line is actually based on the results of the games that we collected. So we can see that they follow each other pretty well, and we can also see that everything is in this range of losing about 3 to 4% of the bet. We can also see that the expected loss is less when we're betting lower multipliers around 1 to 2. We're only losing about 3%, but as the multiplier starts to increase, that's when the loss goes to about 4%. So this graph here kind of shows why it's not going to be possible to beat this game in the long term, because there's just no way to turn these negative expected value bets into something that has a positive expected value. So one way that people try to beat this game is using what's known as the martingale strategy. And this is basically doubling your bet every time you lose to try to make up for that money. Or in this case, doubling your bet every time it crashes below 2. And we can see the total bets here increasing each time that the multiplier crashes below 2, and it eventually reaches 1500. So it looks like people are using this strategy, and it would work if you had an infinite bankroll, but unfortunately there's a max profit of 10,000 on most of these websites. So I found the probability of losing each amount of games in a row, and I put them all into this spreadsheet. So starting with the $2 bet, you can see here we're doubling it each time that we would lose. And the total wagered is just the sum of all the bets so far. And each time you can see that the potential win is exactly $2 more than the total amount that we've wagered. And here we have the probability of losing this many games in a row. So to calculate the expected value, we want to take -1 times the total amount that we've wagered, and we want to multiply this by the probability of losing our total wager. And then we want to add the total profit, and we want to multiply by 1 minus the probability of losing. And this will give us our expected value. We can see that they're all going to be negative. So this strategy has a high probability of winning a small amount of money and a low probability of losing a large amount of money, and the loss actually outweighs the gain in this case. So this pretty much sums up the video and explains why this game is just always going to be in the casino's favor. This was actually the first YouTube video I've ever made, and I really enjoyed making it, and I want to make more videos in the future about probability and money. So if you think you'd be interested in these future videos, please subscribe or leave a like or comment on this video.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem n queens 2. Now we did already solve the first one on this channel, and I would say that this one is actually a little bit easier than the first one. So I do recommend checking out the first video as well if you want to. And this problem is very similar to the first one. I would say it's like 90% identical. So the problem is again about the n queens puzzle, which is given an n by n board. Now the dimensions could be anything. In this case, you can see it's 4 by 4. We want to place then 4 queens, whatever n happens to be, in such a way that none of the queens attack each other. Now, if you're not familiar with chess, a queen, it can basically move in any of the 4 horizontal and vertical directions for an unlimited amount of spaces, and it can also move diagonally, top right, top left, bottom right. So our goal is to place the queens on the board such that they're not attacking each other. You can see that for a board of 4 by 4, we can do that 2 different ways. So in this problem, we want to return the total number of distinct ways that we can satisfy this puzzle. In the first problem, we actually had to create the board for each of the possible ways, but in this case, we just have to count them. So you can see that in the first solution, we were returning the unique solutions. In this case, we're just counting them. So you could actually just take the first solution, take the length of the output array, and then return that. But I'm going to explain this from scratch and then code it from scratch. Logically, this problem is a backtracking problem because we kind of have to brute force it. And when we do brute force it, we think about it in terms of choices. Let's say to make things simple for us, we're picking on the first row. We're placing a queen on the first row, right? Because what we're trying to do is just generate every single combination of how we can place queens and try to place them such that they're not attacking each other. Do it for the first row, do it for the second row, do it for the third row, do it for the fourth row. If we're able to make it to the fourth row and there is a valid position that we can place the queen, then we found a solution and we can increment our result. If we don't find a solution, then we don't increment the result. The goal is to find all possibilities and to make sure that there aren't any duplicates. And the way we're going to do this backtracking, it's actually going to eliminate duplicates by default. Let me show you how. So first row, we have to pick a position for the queen. Let's say we just start with the first one. Now second row, we have to pick a position for the queen, but also before we get to the second row, we know now that we can't place another queen over here. So before we get to the second row, we're kind of just going to take that out of consideration. We're going to remove that. And since we're going row by row, we don't really have to eliminate these positions, even though technically they have been eliminated from consideration because we're going row by row. But now as it comes time to choose a value in this row, we can pick any of these 3. Let's just pick the first one for now, and then afterwards, after we generate the possibilities doing it like this, later we'll backtrack, reverse this decision, and then try all combinations that start like this, and then try to generate those valid ones. But since that was eliminated, we're also now going to eliminate this from consideration. Actually, I just realized this is a good point to talk about the diagonal case. Yes, these are not attacking each other horizontally and vertically, but diagonally they are. So actually it turns out we can't put a queen over here. Now, it's pretty easy to detect horizontally and vertically, right? For this, this queen was placed at this column. So we're just going to eliminate all future possibilities at that position in this column. But for diagonal, it's not so straightforward. But there actually is a clean way to do it diagonally as well, and that's kind of the trick that you have to know. It's really hard to come up with this kind of trick, but when you do, it makes the code a lot easier. It is possible to kind of do it without this trick. Let me just show you. This queen is placed at this position, right? This position is row 0, column 0. Now, if we go diagonally in this direction, and I call this the negative diagonal, but you can call it whatever you want. If we go diagonally like this, we're going to go to the right by 1 and then down by 1. When we go to the right by 1, we're increasing the column by 1. When we go down, we're increasing the row by 1. So notice how the difference between these two values is always going to stay the same. Let's say we're doing it row minus column. We're going to get 0 minus 0, that's 0. We're going to get 1 minus 1, that's 0. We're going to get 2 minus 2 as we go, diagonally, let's say from this position, we're going to get 0. Now, if our queen was actually over here, you can see that that's again going to be true. Here we have 0 minus 1, let's say that's negative 1. Here we're going to have 1 minus 2, that's negative 1. Here we're going to have 2 minus 3, that's negative 1. It's going to be the same idea. But the negative diagonal is not all. Like, suppose from here, we actually also have the left diagonal. I'm going to call this the positive diagonal because, going in the other direction, it shows like a positive line. but again, you can call it whatever you want. But in the positive diagonal, it's going to sort of be a little bit different, because here you can see, okay, we're at row 0, column 2. When we go left diagonally, we are decreasing the column by 1, and we're increasing the row by 1. So it's not that the difference between these two values is going to be the same as we go left diagonal. It's actually that the sum of them is going to be the same, because as we move in this direction, we're incrementing one of them, but we're decrementing the other. So that means that the sum of them is going to stay the same, not the difference. So it's kind of opposite, but the idea is still the same. So here 0 plus 2 is 2. Go bottom left, 1 plus 1 is 2. Go here, 2 plus 0 is 2. So that's the main trick that you have to know. After you know that trick, this problem becomes a basic binary search problem. So we're going to eliminate all the right diagonals for this, eliminate that, and eliminate that. We're also going to eliminate all the values in this column. There's no left diagonal, so don't have to eliminate them. So now we have two possibilities to choose from this row. We're going to, let's try this position. Okay, so we're going to eliminate all, values, positions in this column. And technically, we're eliminating that as well. And just for clarity, I'll say that we're eliminating the values in this row as well. Also, we're going to eliminate the right diagonals, right, going this way. So that's not a possibility. And we're going to eliminate the left diagonals. That's not a possibility. Notice now how in the third row, we can't put
resume this. We back. Dude, why is this such a long message? Oh my god. Some of them. This is no longer an internal error. So in quiet mode, this needs to so we're gonna want quiet mode and not quiet mode. So I'm just now realizing that I've been judging a lot of stuff based on the size of and I've been returning early based on the size of the error manager, but I forgot it's parallel, so like it's not counting just your errors. So let's do just one with an assertion failure. Examples, errors, JSON missing key dot rack. Illegal hardware construction. Yikes. Assertion failed, so that's like at the very end. It's like down here. Where does it say assertion failed? Assertion failed. It's in request. Check assertions. So this shouldn't even exist anymore. Let's go back into request HTTP. Check assertions should not exist. Check assertions. Right, so what did check assertions do? Frick. Let's see if we undo. It did assertions that validate. So we should really just go into assertions that validate. We should do, instead of returning this, assertions. What are assertions? It's a vector of crap. Oh, this is so AIDS. Oh my god. Why did I design this like this originally, dude? This is actually dumb. This should just be an error type. It should just be an error type, dude. An error kind, better. Should be an error kind, bro. Holy guap. Oh, yeah. It's already 11 p.m. Oh my god. Alright, So I'll certainly be fixing that. So live in this. Getting more water after that. That's actually when he So yeah, I'm gonna this is where like the object oriented crap is kind of annoying. Because I have like every possible thing in like a class. Honestly, keep a hoodie in. I don't even need the headphones, let's be honest. I have like everything in a class. Like assertions doesn't actually model any particular object besides just a vector. I mean, what even is the... Yeah, it doesn't even have any data in it. Yeah, what is this? Yeah, this is certainly a blunder here. I mean, having this in a class... yeah, this is not it. So in general, this entire thing needs to effectively combust. There's literally no data in this. It's nothing more than a set of functions in a namespace at this point. Let's compute for a second. The way to do this is to have a assert and a assertion error. So far, if I get, let's go ahead and do here. So this is just being renamed assert effectively. Then we have YT thing, B, P tab, boom, DT under assertion error. Okay. So effectively, okay, so we need to take the functions of this. The data here is going to assertion error. The functions largely are going to assert. Now the set status code, what do these do? Assertion CPP. These return, so set, they return an assertion. This don't expect to chase something else. So it's placing back. Assert. So what is the data? What's the data here? So like what are we doing? We call this. We are parsing this, set a JSON field. So push back. So maybe we should have an assertion type or just a struct. Yeah, this should just be a struct. Assertion.hpp. Yeah, so we do need a struct assertion.hpp. And this can just have do a pragma once. And we'll do a struct assertion. We can just make it capital, yeah. This will have what? So let's go to this. Go back to assertion HPP. Blin. Let's go to assertions HPP. Okay. So we do have these three. This is all the data. So we're going to include vector. Is that it? What's pair product? We're going to include string. We're going to include a regex, which is our local regex. I think it's just a wrapper to regex, yeah. Regex.hpv. So that it is. Right? What is this? I gotta know what this is. This overloads. I Okay, this is just getter, setter, and some other crap. Okay. So going in here, I also want to make a new issue while I'm at it. Private members end in underscore. Frick, I wanted that to be an issue. Convert to issue, request. I'll self-assign this. So this isn't even in the backlog, this is being done right now. I think this is in progress right now. As is this. This is a enhancement in progress. Yep. Let's be real. I'm probably gonna end up doing this. Milestone this 1.0. Good. It's good to me. Nintendo stream OS. So you wanna, okay, you can have that. So expected status codes, expected headers, and expected JSON fields. So these being empty is like their encoding of option. Okay. So assertions. So all of this is getting removed. So let's clear the plane here. Get assertions HPP. So the first thing we're gonna do is move the types to assertion error. So pragma wants. What else are we doing in these error files? Putting these. We can just kind of yank this and change it. Okay. So this is this. No hint. Failed assertion type. So this is more assertion error type. Here. This just doesn't exist anymore because it's not how we do these. That's just a parser error thing. Class. Here we have a assertion error. Yeah, assertion error. DW assertion error. Have a file name. ABT. So an assertion type. Have a assertion error type. So these are all the same severity. So these are just severity. These are test failure. How do you get new severity? So what do we want here? Assertion error type. So there's gonna be more to this. I'll elaborate on that later. Assertion error type. So this, for one, is spelled wrong. Let's do a neck fix right quick. Assertion, so variant malforms, so that's definitely incorrect. Let's do a assertion error type include variant. No. Okay, so that's that done. Print line left that is something else. So okay. So okay. Back to assertions, so that's this. So we do need, this is just in place back, push back. Yeah, that's just in place back and push back for the pairs. So we're just done with this. Besides, so this is just deleted, yeah. Assertions HPP. Now we need to move some of these functions. So all of this is trash. This is trash, this is trash. Validate is useful. So this is what we actually want. So let's paste this into assert. Delete this, and now let's baby this. So this doesn't return anything. These are all void. Void validate. What are you validating? A response. Const assertion. Assertion. So this would be an assertion set. Or is it an assertion? It's an assertion set. I'm gonna rename this. Assertion set. Assertion set. Assertions that should have set request is now asking for a file that doesn't exist. Set assertions does not exist. Response. That stuff exists certainly. Assertions, you don't have assertions anymore because you have an assertion set. Maybe it does have an assertion set. Wait, hold up. Does it have an assertion set? It does have an assertion set, but this is just assertion. Put this in assertion set at HPP. Assertion set at HPP. We have an assertion set. Assertion set. Assertion set. Okay, assertion set, and then we're gonna want getter. It's probably gonna be made with an assertion set. You don't really set it. Frick. So yeah, frick me. Frick encapsulation. Check assertions. So this is now going to be check assertions. Validate. Keep request of value. The request. Get. Request. Get assertion set. Okay, let's do that. So request function const assertion set. Get assertion set. Const return assertion set. Just validate it. So I'm going to do assert.hpp. That way we should have validate. So assert.hpp should just define the function that's in assert.cbb. So validate is void. Assert.hpp void. So pragma wants. Gonna have void function validate. So we're gonna need to include assertion set. Include request. Include response. Let's just copy the header of this from the assertion CPP. Assert CPP. Providing P D D2 down up const non-member function. Yeah, I'm done. Assertion set. Assertion set. It's gonna be used in a second. Oh, it's actually not against an assertion set. Oh, it should be against an assertion set. Yeah, just do it against an assertion set. Okay, so how do you? So I think that's literally it, right? That's what it is. And I have all these helpers. Validate JSON. Honestly, Just make it a fat function, honestly, as zero. Validate status codes. So we should just flatten all of this. Failures, so you don't return failures. You do need an error manager. Include errors / error manager HTTP. We're also gonna need a not cost. We need an so I guess yeah, we don't need that. This not const. And even this isn't const. I don't really understand C++ const. Why is everything const? Because these things change. But whatever. This is what an error. So unknown type name. Okay, so we need to include at least the assert.http. So that should inherit these. That doesn't exist. Validate status. So these. So this. So let's look at this. So this is the first thing we're doing. This is the first thing we do. So let's invite that. You don't return anything. What you're doing here. So SS, you're making a string stream. Okay, that's respectable. Expected one of these status codes. Okay, yeah, okay. So, what do I do here? This is error manager dot add error standard make unique assertion error constructor here. Assertion error, so we're going to consequently include errors / assertion error HTTP. It doesn't know what assertion is. It's going to be an assertion set. Okay, so let's read down the errors. Expected status codes. So this is going to be. Let's name this R, the response. EM. And AS. Assertion set. Assertion set. Oh, whatever. These names are trash. Whatever. R.get status code. So expected status codes. So this is now called AS.expected status codes. AS.expected status codes. AS.expected status codes. AS.expected status codes. And then we're replacing back nothing. What we're doing is making an assertion error. So what does an assertion error have? So make unique. We're going to need to include memory. Error manager. It's not called EM. Maybe word EM. So this can just go out of the window, please. Consider make unique. That's because the constructor is complaining. So you need a file name and a type. So r.em. What is a file name? R response should have a file name. Alright, so we're gonna need a response should really have a file name. This needs a file name, bro. This is what file is this responding to? Standard string. Dude, the amount of context in it right now is like insane. File name. Which is freaking private. Is there no constructor on this? Oh, that's silly. It's response, because we're making a new response. Yeah, I remember that. Frick me, dude. Oh, the amount of context in the dome right now is immense. We make the new response in here by just raw dogging it, or it's in freaking execute, isn't it? Yeah, it's in here probably. Move that away. Response data. To do clean this up with verbose mode and such. Response. So you're setting opt. Set opt header data response. Header callbacks. Must be the case that these are expecting. Yeah, I don't really understand that. Whatever. That's confusing. Response executes. We can just ignore that constructor thing for now. Check assertions, set assertions. So this isn't a thing anymore. Assertions that C++ doesn't exist. Assertions set is equal to a new assertion set. Standard vector int. New assertion set. Move up from assertion set pointer to standard vector int. Standard vector int. That's the status codes. What do you think this is? Assertion set. New assertion set. Okay, is this like the new? So I think that just null makes everything, yeah. So there's that. So back at assert centered, so what's the assertion error have again? You need a file name and a type. So now we got r.file get file name and a type. It's gonna be assertion error type : unexpected status code. Now we need to go into the response, get file name. Let's do standard string get file name const function turn file name here, boom, const declaration does not declare anything. Love that. So let's move on. Let's just do this. Set file name. Not sure how you set it, but we can do it here. Set file name. The const standard string reference file name. Well, I imagine one thing we could do is just set file name underscore is equal to file name. Seems easy. Okay. So back in here, now we have a bunch of other BS about its status code. So I think we just did that, didn't we? No, that's what that was. Header failures. Now let's do that. So validate status code is what I just did. D header failures. So we can just copy this. Same thing I just did, but here. So let's just make a ton of space so I get confused. P. Rip shouldn't have formatted. So this doesn't exist. Expected headers. This is going to be AS that expected headers. R get header value. Instead of doing this, so what we're going to do now is this. So P. Frick, I need to stop pressing that. So instead of doing failures and place back. Unexpected. So this actually needs a message as well. We need a message at the very least. Standard string message. Right. Sorry, no, this isn't part of the. Oh yeah, it is part of the assertion. Message. Here. Let's go here. Const standard string message. Let's go to the implementation of this. Here's it doesn't exist yet. Here's it does not exist yet. Okay, so let's go and do include errors / assertion error. So let's say this assertion error. Sorry, assertion error HPP. Assertion error HJK. So we're gonna need this function. I need just both of these, yeah. That's it. So it's expecting something here, so assertion error, colon, assertion error. We're gonna have a void assertion error details, const override. So now we're here, assertion error. Looking for assertion error must initialize the base class error. Should have a decon constructor. That's a good point. So you gotta come up here, do colon errors. How does it work in the? So we have 1 and 2 now. Let's go back to parser error CPP. It's gonna look something like this, yeah. So the severity is implied. If we go back to here, assertion error CPP. Here, so it's gonna look like this, yeah. So colon error kind, assertion error. So this will be the message, yeah. File name, there. Type. That'll just be the type. Info, so we don't have that. And then, so that void, expected class member base severity. It's going to be error severity, colon, failed test, assertion. So go to the definition of this. Oh my god, now it thinks I'm not talking about the same thing. Assertion, and that's pasted everywhere because I did so much with it. Node assertion, expected class member or base class name. How does parser error do it again? Parser error. Type. Severity. Type. Huh. Class member or base name. Expected class member or base name. What am I missing here? Error. Info. So what am I missing in the assertion error? Details, assertion error. Oh my god. Assertion error HTTP, file name, message, and type. Oh, I'm missing message, aren't I? Message can just be a child of the error, so that was a waste of time. Or can it? No, message is like the title. Okay, there we go. I wish I would just say I was missing that. I think that makes more sense. to do get error kind as a message function. So I can just go ahead and do this because I already did it for the runtime error. This thing as error title. Just do this in the HPP assertion error. It's like this here. So this would be pt underscore assertion error type at switch at. So assertion error type unexpected status code. Got here unexpected status code. Here dt colon assertion error type missing header. Missing required header. Or no, sorry. Missing header. Okay, then we got, honestly it's easier just to type these from the top. Case, assertion error type, unexpected header. Return unexpected header. Case, assertion error type, missing JSON field. Return missing JSON field. This should also be const expr. Case assertion error. Expected JSON field. Return unexpected JSON field. Okay. Back to here, so what I left off doing was trying to get a file name in here, I believe. Make unique. So yeah, I added something to this, that being a message. So that message is ss.stir, so that's what I was doing. Now here, add ss.stir, just the comma there. It's good to me. And we're doing the same thing here, just convenient. Return failures, so that's header failures, so get that out of here. Now let's do JSON failures, so JSON failures. It's just this, yeah, bing, 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 here. So let's get a ton of space. P, so this doesn't exist, but pattern in AM, that expected JSON stores, R, I get JSON key. Failures out of place back, so that's not called this. So instead of ss.stir, it's gonna be this y, so bd down, t ding, y, and then this here, just paste over that key, and there's the key already. Wait, I think I messed that up. Wait, I'm sure. String stream SS. Yeah, I think I messed that up. And what did I identify? AS. Okay, my bad. So what I was trying to do was copy this first. Mark 3 down. And put it here, then do it. So V down, GT, sorry. V down, T, paren, Y, V here, P, save. This is not unexpected status code. This is missing JSON field. This also is an unexpected status code. This is missing header. This is expected header. We got header present, but it wasn't. Header, missing header, unexpected header. this is a just getting deleted. Continue. Sorry, what does it continue doing? If value has somebody continue. Before you start doing crap with the value, okay. So string values value to value, so okay. String values value to value, val, do the substir, shite. Regex match, get regex. In place field, unexpected JSON field. So that's gonna be this. Y open P here V to the end here V bing 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 search an error type missing do something. I'm missing one of these. Sorry, no, I'm missing a comma here. JSON failures. And so we're done. How's that for a little refactor? You feel me? Back to main. So changed all the interfaces. What does that mean here? It means that we don't have a validate anymore. That means we have a. It doesn't mean we have a validate. We just have to. I believe we do have a evaluate. I'm just not passing something into it right. Yeah, no matching call. That's because I did not put in the error manager. Okay, so we can just do here validate assertions. Yeah. Warning here. Non-void function does not return a value. Which one is that? That is standard optional response. Response. Request to execute. Standard optional response. Just turn response. Okay. I believe that's right there. And then we have a test. So yeah, the tests are ruined. I mean, I'm not really concerned with that. Okay, so you got a lot of errors that just haven't been loaded yet. None there. So assert looks fine. Assertion set is fine. So we can really just make all this go into assert. Do one less header. So this is just a cascading error from here. So instead of assertion set, we just need to assert. None of these are actually used. Okay, they are used. So let's go to here, parser. Okay, yeah, so these, so instead of this is assertion. So what is assertions? So yeah, void parse assertion. So parse assertion. What does this return? It sets the request assertions. I do not like that at all. This should not even be part of anything. Parse assertion should return an assertion set. My opinion. headers. Just gonna take a little break, quick. A satisfactory amount of nothing over the last 20 minutes. So what the frick was I doing? I was doing all this. Scheiße. So parse assertion that it does request. So a parser has a request in it. So I'm kind of still trying to figure out what is this doing? Parser parse. And you're parsing it into a request, yeah. So what does a request have? Error manager URL. It's gonna have an assertion set. So it's actually not that difficult. Parse request. Where are the errors? Here. Parse assertion. All the errors are parse assertion. So the request already has, if I'm correct, request, not set assertions. So I think what makes much more sense here is to do parse assertion. This just returns a standard optional assertion set. There's nothing here. You just return assertion set. You go to the beginning, and you do standard, or you do assertion set, and then we're gonna have to go to parser.hpp because this parse assertion should literally just return. See, the thing is, it's operating on the request, like in place. How does that work again? Parse. Parse, what do you do? If you're in the header section, parse the request. So instead of passing in the request, you could just return what it is. So like, what is this doing? This is doing nothing because it sets the method. It sets the URL. So yeah, I kind of figured in case that this is better here. Yeah, realistically, it should be in place. So I guess the thing is, turn type out of line with definition. So yeah, this should be void. What we're gonna do here is have an assertion set. Assertion set. In here, blah, blah, blah. So we can just call it AS because it's gonna take 2 years. I'm gonna be typing this for some time. Dot expected status codes. Dot pushback. Status codes. Huh? Imagine, isn't this a vec? Expected status codes. Or okay. Oh, okay. So this is actually kind of convenient because we can just push it back directly on it. So this is already better. expected status code should actually be just a set. To do make this a set. Maybe it doesn't even matter. Set header, so as dot headers assertion. So these could really just be, oh my god, assertion expected headers dot pushback key value. Mention call to pushback. Headers to pair. What's a pair? So standard pair. Pair. Just a pair. So did he bring back all the errors? It's gonna be there eventually. So the JSON field should be implemented as pairs as well. Not the regex. So this would be as dot expected JSON fields dot push back pair. Just a pair. We can just imply this. VA tick D. Just a pair field value. Knows the type. Just kind of copy this here. If value equals true or value equals false. So it's a string or regex pattern. To do this logic is not correct. Should really just have a regex identifier like R or something. So we're gonna go back here to as.json field. So either way we're doing this. So I feel like this logic can be very much combined if we just do, no matter what we're doing this. But if it's a string, if not these two, frick. To do this logic in general sucks. But I mean, while we're here, I guess we can just paste this in here. Hasn't heard anything, I guess. And then request dot so really, if this returned an assertion set, which I actually like here, turns an assertion set, then we can just do request assertion set. So get a parse assertion type, because we don't have to pass this on the stack and jack. Just call it, get the value, let's state, just set it. So maybe on the request, do a get assertion set. So you should also probably have a void set assertion set. Where do fix in a assertion set as, or let's just do for a consistency assertion set equals assertion set. Assertion set underscore. No viable overloaded. Equal sign. Is it this? Assertion set equals assertion set. Huh? Okay, need the mutable keyword. Okay. We parser HPP. Parse assertions returns an assertion set. Could be the case that there's none of them, but we only go into this if there is. So, so the request. So request.hpp. Sorry. I'm looking for parser.hpp here. Yeah, here. Parser CPP Q. Does not match any declaration of parser. Parser assertions to return a value. So you shouldn't return a value, you should keep eating it. Only functions no return value, return S. Assertion set. Just move it to assert. Is that everything? I edited like 40,000 lines in that. Assertions test is done for. Yeah, this is as good as deleted now. Wow. Okay, let's just run this. So, I mean, that did something. Let's try just running it on data/examples/post.rack. That looks good. /examples/errors/p. Compiling this error parser. That looks quite nice. Let's try JSON V. Huh. So it's printing a response. Expected JSON view. Title. To match pattern food, but it didn't know his bar. Alright, so that one's horrible. Compiling. Running. Okay, so see out. This should not be printed there. Where this should be printed is at the caller. Video. Print, execute. That also just cleans everything up in general. Print, execute result data if successful and write mode. That was a huge refactor. That was a massive. Bathroom right quick. Continue. Doing quite well, actually. Mhm. I'm actually doing quite well today. Let me charge my mouse right quick. Many notable improvements to this project. Should start trying to submit a PR instead of just cascading more features, but meh. So now my task is to make assertions not look like trash. So here, I'm gonna go into the so kind of similarly to how this is done. So first I need to fix some bugs related to error.size. Anytime I'm looking at the error manager dot size, Probably just generalize this to dot size. Here, errors dot size. Maybe it's not. Maybe I'm not doing that as much as I thought. Oh, I'm doing empty. Empty. Error manager. Empty. Empty. Get errors dot empty. So you can't do that because yeah, you can't do that. You'd have to have a local error count. And you have a bool local error exists. False. So this is gonna change local error. So you can just do the difference in the length of the errors, yeah. No, because concurrent. Gonna have to pass around this flag a billion times. Ah, frick, dude. That's a good way to do this. There's really not a good way to do this. This is why we should do the return thing. Because then that could like return an error. Could return some errors and then we push them on at once. Yeah, I should return some errors and then push them on at once. So is there a command just to make this inline? No. I need to request. The problem is there's going to be more and more errors with more and more context as this goes on. So that's going to be kind of a lot. So here, should really just do parse request with the request. Because what does parse request actually do? Parse request. Parse. Let's go to definition. This returns what? A method. String method and a string URL. Yeah, I'll accept that. We're just gonna have to go to parse. Errored. Parsing this, errored. You're gonna have to return errored. Oh my god. So we should just have a, yeah, instead of having it be here, this should just be a member of the parser. Private bool has errored. If we've errored, we need to know if we've added, if we've had a parser error when returning, but can't use the error manager because it's used concurrently by other parsers. And so then anytime there's an error from now on, you set, so like here, so this is like parsing the headers for each one of these. So has errored to get it true. I'm just gonna say this like everywhere. So has errored is equal to true. Should this return immediately? Yeah, I don't think we should be returning like ever here. You should just keep trying. And it might cause a cascade errors, it might not. So you shouldn't set it. So return X value. Return parse request. Yeah, kind of get what it's doing now. Because you don't just want a wrong error. Yeah, we can return. We should have a to-do here. To-do. Should be to not return. Want to get the next error as well. This is if there's no line. So, I mean, either way, the premise stands. So we can paste this. Hazard true. So kind of just doesn't error at all. Set body, so I did to do validate JSON. This is parsing the assertions, the status. Do that. So if this, I should return hazard true. So yeah, you shouldn't return. Should just like continue or some junk. Hazard equals true. And you should continue. Yeah. So I think that's largely correct. Don't immediately remember what I was doing that for. So this is for the has errored thing. So then down here we can go DIA if has errored. So if it's errored, return standard null opt. Otherwise, return this. So assertion is not showing the file. But that did fix the thing. So where else do I use D? So that's fine. Status code is empty is fine. If errors.empty, return. That's fine. Body empty. Get manager. That's fine. Field empty. Next line value. Body empty. Expected status code's empty. Okay, so that fixed that. So now the print assertion error print details is trash. As is the file name. I'm kind of surprised it's not printing the file name properly. Yeah, the file name's just... So it's not even printing error either. So something's definitely wrong here. So let's look at error. There's error.hpp. So first off, we should have a... so first make this switch here. Switch severity. Case. Error severity. Error. This. Case. Error. Severity. Warning. Do this. Case error severity. Failed assertion. Do the same thing effectively. Severity string is going to be failed assertion. And that should be like a terminal color bright yellow or something. So that's what this just did. So else, I think this is a mistake. Print severity, kind. So color, emphasis bold, severity string, failed assertion, error string, error kind to string, assertion, warning. So this should actually be error again, I think. Title, put the padding, the file, error file, file name, framework. I lost a lock on it. Error assertion. So why is now all the errors are freaking? Now all the errors are bright yellow. Oh wait, do I have to break here? Break. Is it that? No, because this is parser. Why is it all yellow? Don't tell me it's a concurrency thing, dude. Error assertion. So this should still be red, honestly. Error assertion. So this should be assertion. Assert. Already trying to do this. So honestly, I'm gonna switch here. Just put this in here, and it just saves like 40 lines. you break here. And you do IT VI ASP DD sorted string error. So you can just DB XX XX error DD break Y down P once ELO running and then it wants search assertion failed. And let's just make it red. We can just make it orange. Make it magenta, sure. Sorted kind, so that's what we just did. So it's really just a comment that you want. You don't even need these anymore either. Title. Title, title. You're going into parser. Message. Assertion error. Message. So the title is the message. Now the title should come from the type. Error kind, so assertion error. Yeah, so this should be that function that we just talked about. So this is supposed to be the message. File. It's saying there's no file. And we should be doing this. So really it should be red again. Really this should just be red. Error. HTTP. This should really just be red. Error kind to string. Error kind to string kind. Assertion failed. It's just gonna say assertion. We don't even need the kind. What we need, error parser. Warning parser. Failed assertion. Runtime. Isn't there also a case? Error kind. But there's a file system error. That might be a child of runtime. So title, print this. Print a file name. File name. So if I go to the assertion error, am I not supplying the file name? File name. So I really need that error kind as message function, which I think I made here. Runtime error type as error type. So I need here as well. So this will go in the assertion error.hpp. And you can do or is it a std string? How does this work here? I should write the whole thing. Okay. So assertion error. So yeah, that kind of makes sense actually. P up Insertion arrow type. Insertion arrow type. AET. Didn't I already do this? Insertion arrow type. No, I swear I did this. I did, it's right here. Oh, I did. I already did that. Okay. It's convenient. So let's go into insertion. Let's go into insertion error. I deleted it. Frick. But even here, insertion error type is our title. Type. We don't even need to supply the type. There's no other utility for the type. Guess we can still have it there just in case. So print details. This is where it's interesting. So this is where we start abstracting stuff into the printer. So, this is right. So this kind of sucks. Insertion failed. Missing JSON field does not print the file. So the file's like null or some crap. Yeah, first off, we can delete this type because it really doesn't need to know anything about it. It's just used to construct the error. Oh yeah, we can go to that. Why would do that? And the constructor can have this changed. Insertion error message. So this is gonna change a lot. But you still need to type here because you gotta construct it. Yeah, that's fine. That to do's gone. So now the print details. Get this on and let's get parser error. So print details. It's got a visitor. This is where things get a little more complicated. So in order to just test this, that I like this, let's implement another parser error type. So an easy one to do. Invalid request line. So that's kind of not it. Expected colon and header line. So you can do this one. This one's solid, so we're gonna v-split this. I'm gonna go up and edit this. So const hint get to a hint with some things in here from 3 to 4, missing closing bracket. From 3 to 4. Inf range. Missing closing bracket. Range in the message. I'm perplexed by that. 3 to 4. Inf range. Off from section header info. Option standard. Hint. This is hurting my brain. Why is it print like that? Finish it, parser error, let's see this plus. The hint. So the hint text, this is already part of the hint. So I kind of just redefined this for no reason. Missing closing bracket. So this should say add a closing bracket. So then why did I repeat this? Section name. Line number, section name. Yeah, so this is supposed to be the section name. Section header info. So that's adding it. This is printing it. That's kind of hard. Because this length, this thing could be like any length. So this is kind of why we should have more of a recursive descent-ish setup. It's not just line by line, parse request, parse headers. Should have more context. So if it's not any of those. If you can find request, then you have like the string in the middle. So this is like where you need more recursive descent. Instead of just going off these tags. Because then you could know what the length of the thing is without a lot of backtracking. So I'm going to postpone that for now. I know it sucks. But expected. So here. So we're going to want let's add this parser error here. This arg info. else if constant spur standard is same the key. And we're gonna have the next type. And we're doing this. So the next one we can have is expected colon. We can call it unexpected. It needs to be way more specific. This is expected colon in header assignment. So we need to make, so everywhere we have malformed section header info. Well, not there, but malformed section header info. Oh, we get another one. So now we have expected colon header assignment. So section header info. So there. So really only two places. So you need a constructor. So, oh yeah, we never actually defined the type. So here, key this, parser error, parser error. What's the next one? Expected. Expected this column v xx v. Yeah, here. Expected colon in header assignment. Okay. Parser type. Expected colon header assignment. So I think you can actually just delete this, yeah. No, you can't. So expected. That's on info. So let's go to the features of this. So standard variant. So I believe this is a variant between all the possible ones could be, yeah. So it's like one of these. I'm gonna have a struct of this. And it'll mostly have the same job. Isn't that right? Info. Parser error. So I need to add it to the parser error HPP. So here, let's have a bunch of these. Parser error. So I believe you could pass in this, yeah. Instead of just having this a ton of times. Just have one of these. Actually, that'd be AIDS. So let's do. Back down here, colon in header assignment info. We're gonna do what we can with that. And at the end of the parser, so we're making a same way we do this. We're gonna do this. Int next time. So here, same thing we're gonna do right here. The hint will be the index of the space. That'll be the index of the space. And then you want to do that more programmatically. So it'll be the standard pair. It'll be from the index of the space. Add. So just say add colon. Right? What does a hint have? Inf range of the message. So the inf range is add colon. And then this could intelligently know what did I do on the left or the right of the char. So the range so frick dt this. We're gonna call this the range. So here, standard pair inf range equals it's going to be equal to, so we're going to have the position of the space. First get index of car and star. Find index. So it's going to be a number. So we're going to have size of t space pause line find space character, because there should only be one space here. Yeah, it's like if you're doing a headers, you're gonna have the space. So I define this. So if space pause is not equal to standard string and pause, you have this. You go to space pause space pause plus 1. We're gonna have the hint. Okay, this. So we're gonna have the this won't be constant. We're gonna have the hint. We're gonna have the hint. Add optional hint. So go to the null opt. Then we're gonna set hint to the hint. Standard option. So I think that should work with the types. UT this hint. It's gonna be a type error. Oh, it knows that I'm doing that again. So the problem now is that I'm not making a malform header section, but I'm making it expected colon header section. Add colon the section name. So that's not a thing. Just dt this line number line and the hint. Okay. And so there's the info. You do the info, the hint, and then you add it. Looks good to me. So then in the printer, get parser error. So then in here, this is where you actually do the thing. So, looks like I'm copying almost all of this. And you can do lead with deadline. Do you lead with a deadline? I'm not confident you want to lead with a deadline anymore. Yeah, I'm not confident you want to lead with a deadline. So the hint text is already a part of the hint. So printing the snippet, you're going to print the line and left padded. Oh. Then it wants to print white space. So, how much white space? How much white space? Snippet. So, how much white space is this going to be? This is going to be. Damn, how much white space is it? We're trying to shift it over. So, minus. This is actually kind of difficult problem. Because what you're trying to do. You're trying to line up this with this. So you're going to have some amount of spaces on this. Some amount of spaces on this. And you want to minimize the amount of spaces. Because this isn't always the best idea. Because you could make the caret over here. Move this outside. You move hint. So to keep it simple, let's just assume you're going to print the hint. Because when you're at this point, when you're printing it, this is not the concurrent part. So you kind of want it all to be over with. As white space. So to print the hint, print line and have the null opt. Bright cyan, bold hint. Then it'll be the hint text. So D, do it right here. Then you're doing so. Damn, this is actually hard. This is a hard problem, dude. Especially with all the prior context on the dome. Do you have it for 5 hours? Dude, this is a hard problem, bro. This is a hard problem. So for now, I'd like to make it simple by just doing the hint. Then I'm gonna have to print that. Expected colon and header assignment info. Function print line left pad void. So I wonder what this is gonna say. Range const. Frick me, dude. So how much white space? It's dependent on the length of the error text. So how much white space is going to be the hint this dot hint. So it doesn't think it has a hint. So info. So how do I access this info? This info dot How do I assert dot arg? So it's called arg. Okay. So arg dot. What does this have? Arg dot hint. So there will be a hint. So that'll be the size. Of arg dot hint. Sorry, it'll be the. Let's see if it's Sterling. Length as string dot length dot size hint dot size hint dot. So what does a hint have? Hint dot value. Oh my god, this is 8. So this has a hint. We're just gonna always assume this has a hint. Hint. Arg dot hint. So what does the hint have? It knows the hint has a inf range and a message. Message dot size plus the arg dot hint dot message. Sorry. Arg dot hint dot inf range dot first. CBP pair first. Is it a method or a member? to memory. So that's how much white space we want. We're gonna print that. Plus. So the first is going to be the index. We go into it. Holy guap. I'm going to do the inference stuff first. Arg.snippet. Okay. So we should really abstract these into functions. Into your printer, into a bigger printer. So then we're going to have hint this. Oh my god. Hint. That size. So this is 6. Hint. It's gonna be standard string as white space. Inf. So arg.hint.inf range dot second. That's arg.hint.inf range dot first. Okay. We're back. What's the error here? Yeah. Can't make a hint. So this is in parser. Parser CPP. 143. Trying to make a hint. So I'm putting in a hint. And it wants a hint. Repair infringe hint, reassigning hint. Standard. Make optional hint here. Green. From hint to repair. This thing wants a hint, right? No, it doesn't want optional. It wants a real hint. Because it's assuming there will be a space. So let's just do else repair infringe. That's not gonna know what that is. Oh, blight. Repair infringe. Just 0, 0 at that point. Here and DT here and infringe and is equal to hint and okay. So that still looks like poop, but here we can do PE malform section header. Then we can do PE expected header colon rack GG0Y up. I should delete all this. Grab post rack G up, bang, no body, nothing else, just here, headers. You can just imagine there's, okay, wait, that's kind of a bad example. Imagine there's just a space there. Green. You probably enable comments. Make comments at some point. Expected colon and header assignment. Hint. Add colon. So let's go to add colon. So it's printing that. Let's go to the reference of this and printing this. So we need to go to parser error CBP where we're actually printing it here. So we're printing the string second dot first. Here 1. So this is like a general thing. Plus 1. It's gonna be quite small, yeah. Colon space. And does it go to this space? And does it go to this? Space this. And this should probably be bold, right? And format emphasis bold on this. So actually I want this part to be bold. You want the hint part to be bold. You want this part to not be bold. to say hint space. Do this. And you know this part should not be wrong. Actually say what the hint is, and then you know this part too people. So say what that is. Add colon. So this is like way off. But that calculation is currently irrelevant because we're trying to offset it by 6 plus the length of this minus the amount of text to the left of the space, which is going to be what? So, we should really recursive desynthesize this. I think it should be like identifier. We can just backtrace. Is that a word? So this should be the number of characters in the original text. Is there a line on here? Yeah, you get access to the line. Snippet. It's called snippet in this case. Snippet. It's the line. So this is like in the snippet. Position retroactively of the space. So the better way to do this is know the position that we're trying to put a caret in is what? Position in space is the first. So that's going to be parser. That's going to be minus plus arg inf range hint at first. So it's going to be 6 hint colon space plus the message size. Minus this. Six plus the message size. So add colon space. Plus 1 minus the range of the first, which is going to be like, range of the first is going to be like a lot. Right? Like, what is this? Standard cout arg int inf range first. Indow standard indow. Arg hint and range first. Response explore. Oh my god. Why does this not work? Standard CO. Include. Manage. Oh my god. Can't actually see out anything. FMT print argent and range at first. Zero. I think that's 0, 0. So this is definitely incorrect. And this is not right. Not equal to this. Standard cout. Space pause. Standard inline. Didn't know there was a function. Inf range is going to be equal to space pause. So this is exclusive. Because that's exclusive. And 12. 12 makes sense. 12. 13. So it's just going to be 1 at position 12. Hint, we're making a new hint. Compare inf range, expected here. Hint is hint. And I'm putting that in the info, make sure parser error of that has error true. D2 down. Has occurred is certainly true. Okay, and then in here, so we have hint. Hint, hint. Parser error. It's the second minus the first. Yeah, this will be +1. Exclusive. 6. Inf range first. Makes no sense. Thinks it's 16. 6. Arg. It's this. Hint. Hint. Inf range. Why does it think this is not that much? First is this. T is this. BT minus sign XX. F0 T16. Inf range. So it even knows what that is. Infringe is a pair. Pair. You have a first and a second. You have a hint. Hint, hint. What? Not picking up on it. But wherever I make this, it's only in one place currently. The range is certainly larger than it thinks. Standard, see out. And range. No. Should I print that? No. Not first. Print the first one. Right here, everyone. Let's do it. I get this hint that in range. So let's say it's 0. Hint that in range at first. Is equal to a standard pair. Zero. Standard pair. Infringed at first. Space pause. Space pause. End up find. What? Standard pair. And space pause and pause. 12 plus 1. So the way those to do bounds check. Slash errors slash PE expected for this. And add colon. Okay, so it's gonna save this. It's gonna parser error C++. So still not the right amount of subtracting here. So method says +1. So the printing of this doesn't need to be like that anymore. That way we get one of them. So I think it's actually right if you just don't count this doing this. green, CD, CD air, build. So it always has a line above. I agree, that'd be kind of nice. Print line on the Fed. No pointer from the left. Let's start with this. Start with this. So the new line, it's not actually what that was as much as I would think before. Yeah, I needed this. That makes sense. Print line and left pad for my print line. Yeah. Well. So where am I printing 12? Out. Alright, so that looks pretty good now. If you just consider the PE ones, or we can just consider all of them. Add closing bracket there, add colon there. Now the assertions are doing one of the trash. Just solve. Hint, add colon. Compiling, bing, bing, bing. Running, bing, bing. So, it's because the printing of all the errors is done in one thread. That's why it's not messed up. And CPP. So, printing errors done in main thread. Printing the other junk is done here. Which is why it doesn't do that well. Maybe the printer should have a concurrency guard as well as semaphore. Tuple variant defined here. Type shows past. Mismatch types guard. That's pretty solid actually. So now assertions look like trash. There's no file name. And there's no assertion type. So the assertion one can be a lot easier. Because you can do like a diff. So you try to find the diff. Suppose find diff. Diff text. Diff is on bad. Закидывай решать. So I'm getting kind of tired, for real. I'll start doing the assertion failed. So first off, this. Oh my gosh. So yeah, I don't like this as much. I'd rather just have space this error. This one, so error. Parser error. Search. Error. Parser error. Parser warning. Yeah, that's fine. You have like parser error, parser warning. Runtime warning. Assertion warning. Assertion error. Assertion failed. So assertion error print literally does not exist at all. So what are the types of assertion errors? Because I had this like parser error has this like standard variant. Parser. I mean, runtime error has no. Just print the message. All assertion errors have the same jock. They have the, because if you look at this, these are the type of assertion they have. Status and JSON field. So assertion error. So let's go back to this. There's going to be more in here. There's going to be a standard. There's going to be basically everything that's in the malformed. So let's go here. Let's search for the error. Dot. Let's make it parser error HPP. Yeah. So there's going to be most of this. We have a line. We can make it a line number. Snippet. Hint. do you make a constructor that has the hint? So you have this file, and you have HPP. HPP has these three. File name, message. Message here. What's the message? So there's not gonna be a message anymore. There you have the title, yeah. Yeah, there's not a message anymore. Yeah, that should just get deleted. Typical element should have a file name, should have a const int line number, should have a const standard string. It's the pointer that's constant. Snippet. There's gonna be no hints on this. This is like diff. This is like a new like diff type or something. Let me look at a GitHub diff. So when you do a diff, this just made a ton of crap. You do minus red, minus a line in red, and then you do plus a line of green. So when the assertion fails, it should probably look like what should that look like? The assertion fails, so I don't know yet. I don't think it matters because you just have the standard snippet on the line. So you don't have that anymore. Assertion error file. You have the const standard string pointer snippet. And you have the const int line number. You do line number, snippet. You're done. Then we're doing the same thing that we do in the other ones. So look at parser error.cpp. You just do this. I better this. So print line and left pad. This should definitely be a printer function. Yeah, this is definitely something you see in printer.hpp. Same with the as white space. That's define an arrow TPP. That should be in printer.hpp. Inline. That's going to increase the binary size a lot. And we can just inline. Inline for print line. Frick. That's kind of a big function. It's got a loop in it. It's not going to be as good for inline. We do inline this. That just broke everything. So we need to include printer. It doesn't know what arg is, and it's supposed to parser error. So that's supposed to be messed up right now. Assert make unique. Matching constructor for assertion error. Line number. Fuck. It's expecting a snippet. So maybe the assertion set should instead be a vec. Assertion JSON fields. JSON fields should be bigger. Should be a vector of a nested type. Struct. It needs what the expected is. It's a pair of string and regex. It needs the expected and the response has retrieved. So the assertion error can have a few types, right? And this is why we do the const expr thing with a status code. Header JSON field and all this because they're going to have different content. For now, let's just not make this as complicated. Instead, we won't have a line number and a snippet. Alright, I'm gonna pause here. I'm getting so tired, dude.